Imagine a world where the weather is no longer something completely unpredictable, a world where governments and major technology companies can not only forecast rain or drought, but also partially influence them. Not long ago, this idea would have sounded like science fiction or the plot of a movie about the future. Weather has always seemed like one of the few forces of nature that remain entirely beyond human control. We have learned how to build cities, lay cables across oceans, launch satellites into orbit, and even alter the genetic code of living organisms. But the Earth's atmosphere, with its complex air currents, clouds, storms, and climate cycles, has long remained a system that humans could only observe and try to understand. Over the past few decades, however, this perception has gradually begun to change. In different parts of the world, technologies are emerging that allow scientists to influence atmospheric processes. Aircraft release special particles inside clouds in an attempt to trigger rainfall. Drones are testing new ways to generate precipitation in dry regions. Some countries are experimenting with systems designed to disperse hail clouds or reduce the risk of severe storms. This is not full control over the weather, but it represents the first steps towards something that, only a few decades ago, seemed almost impossible. Interest in these technologies is growing rapidly. Agriculture depends on rain. Cities depend on reliable water supplies. Droughts can destroy harvests, while powerful storms can cause billions of dollars in economic damage. In a world where the climate is becoming increasingly unstable, the ability to influence atmospheric processes, even slightly, is shifting from a scientific curiosity to a strategic technology. That is why governments, research institutions, and private companies are beginning to invest enormous resources into the development of what are known as weather modification technologies. According to some analysts, the global market for weather modification technologies could reach tens, perhaps even more than $100 billion in the coming decades. And some of the most ambitious programs are already underway in a handful of countries. Among them is China, which has built the largest weather modification system in the world, covering vast areas of the country. This program has become the foundation for one of the most ambitious experiments in humanity's attempt to influence the atmosphere. And this raises a question that, not long ago, would have sounded strange. What happens if weather stops being just a natural phenomenon and gradually becomes something humans can partially design and control? That question is where the story of one of the most ambitious technological projects of our time begins. A plan that some analysts already describe as an attempt to create a system for controlling the weather. Interestingly, the idea of influencing the weather appeared long before modern technology. For thousands of years, people have tried to find ways to control rain, storms, or droughts. In many cultures, there were special rituals, prayers, and entire ceremonies intended to bring rain, or, on the contrary, to stop heavy storms. For agricultural societies, weather was often a matter of survival. A single bad season could mean famine, economic collapse, or even the decline of entire civilizations. For a long time, however, all of these attempts remained purely symbolic. Humans could observe the weather and try to predict it, but they had no real way to influence atmospheric processes. The Earth's atmosphere is an incredibly complex system. Temperature gradients, ocean currents, airflows, water vapor, and countless other factors interact with each other at the same time. Even today, in the age of satellites and supercomputers, accurate weather forecasting remains a difficult task. Because of this complexity, the idea that humans might actually change the weather was long considered little more than fantasy. That perception began to change in the middle of the 20th century. It was during this period that the first scientific experiments showed that certain atmospheric processes could at least be partially stimulated. In 1946, American researchers conducted an experiment that became one of the most famous in the history of meteorology. They discovered that releasing certain chemical particles inside a cloud could accelerate the formation of ice crystals or water droplets. As a result, the cloud could begin producing precipitation more quickly. This method became known as cloud seeding. The basic principle is relatively simple. Tiny particles are introduced into the atmosphere, where they act as what scientists call condensation nuclei. Water vapor begins to gather around these particles, forming droplets or ice crystals. When these particles grow large enough, they fall to the ground as rain or snow. In other words, Humans are not creating clouds from nothing, but they can push along a natural process that is already happening in the atmosphere. For its time, this discovery seemed almost revolutionary. For the first time in history, there was a scientific method that allowed humans to influence the weather, even if only slightly. And although its capabilities were limited, the idea that people could stimulate rainfall quickly attracted the attention of governments and scientific institutions, especially in countries where climate conditions had a major impact on the economy. By the second half of the 20th century, experiments with weather modification were already taking place in different parts of the world. The United States tested cloud seeding technologies in agricultural regions. The Soviet Union used similar methods to reduce the risk of hailstorms that could damage crops. Some countries attempted to increase snowfall in mountainous areas in order to improve water resources. All of these experiments demonstrated one important idea. Weather cannot be fully controlled, but under certain conditions, it can be nudged slightly in a desired direction. From these relatively small experiments, an entire field gradually began to emerge, what is now known as weather modification technology. At first, these were small scientific programs, but over time, some countries began to view these technologies not just as a scientific curiosity, but as a strategic tool, and no country has taken this idea further than China. Today, China operates one of the largest and most ambitious weather modification programs in the world. While in most countries, such technologies remain relatively small experimental projects, in China, they have gradually evolved into an entire infrastructure system. Over the past few decades, the government has invested significant resources into building networks of installations, aircraft, rocket systems, and meteorological centers capable of conducting so-called cloud seeding operations across vast territories. The reasons behind China's interest in controlling weather are largely practical. The country has one of the largest agricultural systems in the world, and a significant portion of its food security depends on stable weather conditions. Droughts can severely affect harvests of grain, rice, and other crops that feed hundreds of millions of people. For that reason, the ability to slightly increase precipitation in critical regions appears to the government as a strategic instrument. In addition, China faces major regional imbalances in water resources. In the northern parts of the country, where some of the largest cities and industrial centers are located, water is far more scarce than in the southern regions. Under these conditions, technologies that stimulate rainfall can help replenish reservoirs, maintain river levels, and reduce the effects of drought. For a country with a population of more than 1 billion people, even a small increase in precipitation can have a significant economic impact. But China's weather modification program is not used only to fight droughts. It is also applied to reduce damage from hailstorms that can destroy crops in agricultural regions. In some cases, cloud seeding technologies have even been used to manage weather during major national events. One of the most famous examples occurred during the 2008 Summer Olympics in Beijing. At that time, Chinese meteorologists attempted to trigger rainfall outside the city before storm clouds could reach the stadium, allowing the opening ceremony to take place without rain. Over the years, the scale of this program has continued to grow. China has created an entire network of specialized installations capable of launching rockets filled with chemical agents that release particles into clouds. Aircraft, meteorological satellites, and ground-based observation stations are all involved in these operations. In some regions, these systems operate regularly, particularly during seasons of drought or when the risk of hailstorms is high. In 2020, China announced plans to significantly expand its weather modification program. According to official statements, by the middle of the decade, the system is expected to cover several million square kilometers. That means technologies designed to influence atmospheric processes could operate across areas larger than many entire countries. For this reason, some analysts have begun describing the program as one of the largest experiments in humanity's attempt to influence natural processes on a planetary scale. However, China is far from the only country experimenting with weather modification technologies. Interest in these solutions is growing in many regions of the world. And the more an economy depends on stable climate conditions, the more attractive the idea of partially managing atmospheric processes becomes. That is why, in recent years, a new technological race has begun to emerge. One in which different countries are searching for ways to make the weather a little more predictable and perhaps even somewhat controllable. The reason interest in these technologies is growing so rapidly today comes down to a simple economic reality. Weather affects almost every sector of the modern economy. Agriculture depends on rainfall, energy production depends on temperature, river water levels, and wind strength. Transportation systems are affected by storms, fog, and snow. Even financial markets sometimes react to weather conditions when extreme climate events disrupt production or logistics. For agricultural regions, a single dry season can mean the loss of a significant portion of the harvest. For megacities, water shortages can create serious social and economic problems. That is why the ability to slightly influence rainfall or reduce the risk of dangerous weather events appears extremely attractive to governments. Even if a technology can increase precipitation by only a few percent, on the scale of large economies, that can translate into billions of dollars in additional value. Beyond China, active weather modification programs exist in the United States, the United Arab Emirates, Australia, and several European countries. In the United States, cloud seeding is used in mountainous regions to increase snowfall, which later replenishes reservoirs. In Australia, similar programs help support water resources in dry areas. And in the United Arab Emirates, where natural rainfall is extremely rare, the government funds experiments with drones and new technologies designed to stimulate rainfall. In some cases, these experiments look quite unusual. Researchers have tested the use of drones that release electrical charges inside clouds in order to stimulate the merging of water droplets. Other projects are exploring the possibility of using lasers to create microscopic condensation particles in the atmosphere. At the same time, modern artificial intelligence systems are being used to analyze enormous volumes of meteorological data in order to determine when and where cloud seeding operations might be most effective. All of this means that weather modification technologies are gradually moving from the realm of experimental science into the field of applied engineering. Specialized companies are beginning to appear that focus specifically on modifying precipitation. Governments are creating entire water management programs in which these technologies become part of national infrastructure. And although these methods still have limited capabilities, their development shows that humanity is beginning to take the atmosphere more seriously as a system that can at least partially be influenced. However, these new possibilities also raise new questions. If countries learn how to stimulate rainfall in a specific region, could that affect weather patterns in neighboring countries? Could weather modification create new geopolitical tensions? And is it possible that in the future the atmosphere could become another arena in which nations compete for technological advantage? These questions are gradually shifting the discussion of weather control from the realm of science into the fields of politics and strategy. History already contains examples of atmospheric processes being used not only for economic purposes, but also for military ones. And for that reason, any conversation about weather modification technologies eventually leads to one of the most controversial chapters in this story. One of the most debated episodes in the history of weather modification was a program known as Operation Popeye, carried out by the United States during the Vietnam War in the late 1960s. The goal of this operation was to use cloud seeding technology to extend the rainy season in certain regions. The idea was that increased rainfall could make it more difficult for enemy forces to move military convoys and supplies, especially along the well-known network of roads used to transport resources. As part of this program, aircraft dispersed chemical agents into clouds above the jungles in an attempt to stimulate additional rainfall. According to some estimates, the operation lasted for several years and covered large areas. Although its effectiveness remains a subject of debate among researchers, the very fact that weather modification technologies were used for military purposes triggered serious international discussions. After information about the program became public, many countries began expressing concern that atmospheric processes could become a new kind of geopolitical tool. If one country were capable of influencing rainfall or weather conditions in a specific region, this could potentially affect neighboring territories as well. The atmosphere does not follow political borders, and any intervention in its processes can spread far beyond the area where it was originally intended. For this reason, an international agreement was signed in 1977 known as the United Nations Convention on the Prohibition of Military or Any Other Hostile Use of Environmental Modification Techniques. This document, often referred to as the ENMOD Convention, prohibits the use of environmental modification technologies, including weather modification, as a method of warfare. The idea was to prevent the emergence of a new category of so-called environmental weapons that could alter natural processes across entire regions. However, even with the creation of this agreement, interest in weather modification technologies did not disappear. Most programs in different countries are officially described as purely civilian initiatives designed to support agriculture, manage water resources, or reduce damage from extreme weather events. Yet the history of Operation Popeye demonstrated that the ability to influence the atmosphere could have much broader implications than simply increasing rainfall. And this leads to another important question: how realistic is it to talk about controlling the weather at all? Do modern technologies truly allow humans to manage atmospheric processes, or do most of these programs simply push natural phenomena slightly in a direction they might have taken anyway? To understand this, it is necessary to look more closely at how Earth's atmosphere actually works, and why full control over weather remains far more complex than it might sometimes appear. To understand the limits of these technologies, we first need to recognize how incredibly complex the Earth's atmosphere really is. Weather forms through the interaction of a vast number of factors: temperature differences between oceans and continents, the circulation of air masses, humidity levels, solar radiation, the shape of the landscape, and even the state of ocean currents. Each of these elements influences the others, creating a highly dynamic system that is often described as chaotic. This is precisely why even weather forecasting remains a complex challenge. Modern meteorological services rely on satellites, radar systems, thousands of ground-based observation stations, and powerful supercomputers to model atmospheric processes. Yet even with these tools, the accuracy of forecasts is limited, especially when it comes to long-term predictions. A small change in atmospheric conditions can lead to very different outcomes just a few days or weeks later. In this context, it is important to understand one key idea. Most modern weather modification technologies do not create weather events from scratch. Instead, they attempt to influence processes that are already taking place in the atmosphere. For example, cloud seeding can help accelerate the formation of rainfall, but only if clouds containing sufficient water vapor already exist in the sky. If the atmosphere is too dry or the conditions are not favorable for precipitation, these methods simply do not work. This means that modern technologies are better described as tools for adjusting weather rather than fully controlling it. They may slightly increase the amount of rainfall, reduce the risk of hail, or encourage rain to fall from a particular cloud sooner than it otherwise would. But they cannot create a storm in a clear sky or stop a powerful hurricane. The atmosphere remains a far more powerful system than any technology currently available to humanity. Despite these limitations, interest in developing such technologies continues to grow. Part of the reason is that even small changes can have significant economic effects. If a cloud seeding system can increase rainfall by just a few % in a drought-prone region, it may translate into additional water resources for millions of people or improved agricultural yields. On the scale of entire countries, even a modest influence on atmospheric processes can become a meaningful economic advantage. In addition, the development of new technologies is opening possibilities that only a few decades ago seemed unreachable. Modern satellite systems allow scientists to observe cloud formation and the movement of atmospheric fronts with far greater precision. Unmanned aerial vehicles can operate in parts of the atmosphere where sending aircraft used to be difficult or expensive. At the same time, artificial intelligence systems are capable of analyzing enormous amounts of climate and meteorological data in order to identify the most effective moments to intervene in natural processes. All of this is gradually forming a new field that is sometimes referred to as weather technology or weather engineering. Its goal is not complete control over the atmosphere, but rather the creation of tools that help societies adapt more effectively to climate conditions. In a world where climate change is making weather events increasingly extreme, even a limited ability to influence atmospheric processes could become an important part of future infrastructure. And this leads to another interesting idea. In the future, technologies that influence weather may be viewed in much the same way we view dams, irrigation systems, or power plants today, as pieces of infrastructure that help societies interact with natural processes in a more predictable way. If that happens, the atmosphere could gradually shift from being a completely uncontrollable force of nature to a system in which humans are at least capable of adjusting certain elements of its behavior. Although humanity is still far from having full control over the weather, the very idea of influencing it is already beginning to change how we think about Earth's atmosphere. Just a few decades ago, weather seemed like something people could only observe. Today, however, it is slowly becoming a domain in which humans are not only trying to predict the future, but also, in small ways, to shape it. For this reason, an entirely new economic sector is beginning to form around weather modification technologies. In the past, experiments in this field were funded mostly through government scientific programs or military research. But in recent years, private companies, startups, and technology investors have started entering this space more actively. They see weather technology not only as a scientific curiosity, but as a potentially large market that could expand significantly in the coming decades. The logic behind this growing interest is fairly simple. In a world where the global population continues to grow and climate conditions are becoming more unstable, the management of water resources is turning into one of the key challenges for modern economies. Droughts can destroy crops, reduce hydroelectric power generation, and create water shortages in major cities. Floods, on the other hand, can cause enormous damage to infrastructure and residential areas. In such circumstances, even limited technologies capable of influencing atmospheric processes could have enormous economic value. This is why analysts are increasingly talking about the potential emergence of a global market for weather modification technologies. According to various estimates, the size of this market in the coming decades could reach tens or even hundreds of billions of dollars. It could involve companies developing drones for cloud seeding, manufacturers producing specialized chemical agents, developers of meteorological satellites, and firms building software platforms for analyzing atmospheric processes. Another direction of development is closely tied to artificial intelligence. Modern machine learning systems are capable of processing massive volumes of climate and meteorological data in order to detect patterns that are difficult for humans to identify. This allows researchers to more precisely determine when cloud seeding or other atmospheric interventions are most likely to be effective. In the future, such systems could evolve into sophisticated platforms for managing atmospheric operations, functioning in ways similar to how today's systems manage power grids or transportation networks. However, the growth of this industry also brings new challenges. One of them involves international regulation. If one country actively uses weather modification technologies, this could potentially influence climate conditions in neighboring regions. For example, stimulating rainfall in one location could theoretically alter the distribution of moisture in the atmosphere, raising difficult questions about who effectively owns rainfall within a shared global atmospheric system. Another challenge is that the effectiveness of many of these technologies is still debated within the scientific community. Some studies show positive results, while others question the true scale of their impact. The atmosphere is such a complex system that it can be difficult to determine whether a particular weather change was caused by technological intervention or whether it would have happened naturally anyway. Yet despite these debates, it is clear that interest in controlling, or at least partially managing, weather continues to grow. In a world where economies are increasingly dependent on stable climate conditions, the ability to influence the atmosphere could eventually become a strategic technology comparable to energy systems, water infrastructure, or space-based observation networks. For this reason, some researchers have begun suggesting that the 21st century could mark a gradual transition from an era in which humanity only predicted the weather to one in which it attempts to partially design it. Not to fully control it, at least not yet, but to influence certain atmospheric processes enough to change the economic and social consequences of climate events. If these technologies continue to evolve, it is possible that one day weather will no longer be viewed purely as a random force of nature, but as another domain in which humans attempt to build systems of management and control. And this leads to an even more fundamental question. If humanity gradually learns to influence atmospheric processes, even on a limited scale, how might this change our relationship with nature? For most of human history, weather was a force that people simply had to accept. It could bring abundant harvests or destroy them, fill rivers with water, or create devastating droughts. Civilizations were built by adapting to climate conditions, not by altering them. Today, however, that logic is slowly beginning to change. Humans already intervene in natural systems on many levels. We redirect rivers, build massive dams, manage water resources, and even attempt to influence global climate processes by reducing, or in some cases increasing, emissions into the atmosphere. In this context, weather modification technologies can be seen as another step in a long historical process in which humanity gradually tries to shape and manage the natural environment. However, the atmosphere is perhaps one of the most complex systems on the planet. It surrounds the entire Earth, constantly moves, and responds to countless interacting factors. Even small changes in one region can sometimes produce unexpected consequences in entirely different parts of the world. That is why many scientists emphasize that any attempt to actively interfere with atmospheric processes must be approached with great caution and supported by serious research. And yet, despite all these complexities, interest in this field continues to grow. The climate is becoming increasingly unpredictable. Droughts, floods, and extreme weather events are becoming more frequent in many regions of the planet. For governments responsible for water resources, food security, and economic stability, the possibility of even partially influencing atmospheric processes appears to be a tool worth exploring. This is why experiments with new technologies are continuing in different parts of the world. Some countries are investing in networks of cloud seeding systems. Others are studying new materials that could serve as more effective condensation nuclei in clouds. Certain scientific groups are even exploring theoretical approaches that could influence atmospheric flows on much larger scales. For now, all of this still looks like the early stage of a much larger experiment. We do not yet know how far humanity will be able to go in its attempts to influence the weather. These technologies may remain relatively limited tools used mainly for water resource management. Or several decades from now, they could evolve into far more advanced systems that allow societies to interact with atmospheric processes in more sophisticated ways. That is precisely why the plans to build large-scale weather modification systems, currently being explored by some countries, are attracting so much attention. For some observers, these projects represent an extraordinarily ambitious technological strategy. For others, they appear to be a risky experiment involving natural processes on a planetary scale. But regardless of how these initiatives are interpreted, they demonstrate one important reality. Humanity may be gradually entering a new era in which Earth's atmosphere becomes another environment shaped by technological influence. And perhaps, several decades from now, we will look back at today's weather modification experiments in the same way we now look at the first power plants or the earliest space rockets, as the beginning of a long process in which humanity tries to understand one of the most complex systems on Earth and to learn how to interact with it, even if only in small ways. If we look at this entire story from a broader perspective, it becomes clear that technologies designed to influence weather are not just a matter of science or engineering. In reality, they are part of a much larger process in which humanity gradually expands the boundaries of its control over the natural environment. Throughout different periods of history, people have learned to manage various systems of the planet. At first, it was rivers and irrigation canals that allowed the creation of the earliest agricultural civilizations. Later came energy systems that made industrial economies possible. Then global transportation networks and space satellites emerged, allowing humanity to observe the planet from orbit. For a long time, the atmosphere remained one of the few systems that humans could study but not truly influence. Yet even here, the situation is slowly beginning to change. First came forecasting technologies that allowed scientists to better understand weather processes. Then, early warning systems for storms and extreme weather events were developed, helping societies reduce the damage caused by natural disasters. And now, the first tools are beginning to appear that allow humans, at least on a small scale, to influence certain atmospheric processes. In this sense, attempts to modify weather can be viewed as the early stage of a new technological era. For now, these technologies are still far from providing full control over the atmosphere, but they demonstrate that even such a complex system is gradually becoming an object of scientific research and technological experimentation. What today looks like limited intervention in natural processes could eventually evolve into more sophisticated systems for managing climate-related risks. That is precisely why large-scale weather modification projects attract so much attention. They demonstrate not only the technical capabilities of modern science, but also a shift in how humanity approaches its relationship with nature. Instead of simply adapting to climate conditions, some countries are beginning to explore the possibility of actively managing certain aspects of the atmosphere. At the same time, however, this raises new ethical and political questions. If weather becomes an object of technological influence, who will decide when and where these technologies should be used? Will they remain tools for economic and environmental management, or could new forms of international competition emerge around atmospheric resources? And how should a system be regulated in which interventions in one region might have consequences for other parts of the planet? For now, there are no clear answers to these questions, but it is already obvious that interest in this field will continue to grow. Climate challenges are becoming more serious, and modern economies are increasingly dependent on stable environmental conditions. In such circumstances, technologies that allow even partial influence over atmospheric processes could become important tools for adapting to a changing world. And this is why the story of attempts to control the weather is not simply a story about clouds, rainfall, or scientific experiments. It is, in fact, a story about how humanity is gradually trying to understand and interact with one of the most complex systems on the planet. And perhaps, several decades from now, the technologies that seem experimental today will become a normal part of the infrastructure of the modern world. Because if the history of technological development teaches us anything, it is that many things that once seemed impossible eventually become ordinary parts of everyday life. And it is entirely possible that one day we will look back at today's weather modification experiments as the first steps in a long process that will transform how humanity interacts with Earth's atmosphere. And when you look at all these experiments, hundreds of projects, aircraft seeding clouds, drones testing new ways of generating rainfall, government programs covering millions of square kilometers, you begin to realize something important. Humanity is gradually approaching a boundary that, until very recently, seemed completely unreachable. We have always been used to thinking of weather as a force of nature that exists independently of us, something that can be predicted with greater or lesser accuracy, but never truly changed. Yet today, that boundary is slowly beginning to shift. Technology still does not allow us to fully control the atmosphere. We cannot create hurricanes, shut down storm systems, or precisely determine where and when rain will fall. But we are already taking the first steps toward influencing certain atmospheric processes. And even this limited influence is gradually changing the way people think about weather. Perhaps in the future, these technologies will remain only supportive tools, methods to slightly increase rainfall in drought-prone regions or reduce the risk of dangerous weather events. But it is also possible that they will become the beginning of a much larger system, one in which the atmosphere gradually turns into another layer of infrastructure within modern civilization. And that is why the story of plans to control the weather, projects worth tens or even hundreds of billions of dollars, is not just a story about technology. It is a story about how humanity attempts to expand the boundaries of what is possible, about how we are gradually moving from a world in which nature completely defines the rules of the game toward a world in which humans attempt, at least partially, to rewrite those rules. Perhaps, in a few decades, many of the experiments that today seem ambitious or even slightly fantastical will become an ordinary part of the infrastructure of the modern world. Or perhaps we will discover that the atmosphere is simply too complex a system to truly manage. But regardless of which of these scenarios becomes reality, one thing is already clear. Humanity is no longer satisfied with simply observing the weather. We have begun to ask a different question, not just what the weather will be tomorrow, but whether one day we might learn how to change it. And the answer to that question may become one of the most fascinating technological challenges of the 21st century.